is one of the ceramics pots found in bamboo set. It is very beautiful. Can you imagine that our ancient people were able to make ceramics more than 6,000 years ago? The Terracotta Warriors Museum is another world-famous tourist attraction. These terracotta sculptures are made on a large scale in Qing Dynasty about 2,200 years ago. Those two stories lead us to one of the main topics of this video, that is ceramics. Let me ask you one question firstly. Why did those ceramics remain in a good looks even though they have been buried in the ground for thousands of years? One reason is that ceramic materials have good chemical stability. Another interesting fact is that although we saw a lot of terracotta warriors, but only one was intact. That means not broken when it was founded. Because ceramic materials have their own shortcomings, ceramic materials are usually brittle. They are not tough enough. The two ceramic antiques we just mentioned is one kind of traditional ceramics. It's a little bit difficult to explain what is ceramics, but it is easy to understand. What kind of material is ceramic materials? Ceramics now include domestic, industrial, and building products. It also includes a wide range of ceramic art. There are many different ways to classify ceramics. One way is to define ceramics by their applications. Most ceramics material include the following group: glasses, structural clay products, whitewares, refractories, abrasives, cements, and newly developed advanced ceramics. Now we will give a further description of each group. The glasses are a familiar group of ceramics. We can see them every day, everywhere. The major advantage of glass material are their optical transparency. Their typical applications are containers, windows, lenses, and fiberglass. Most glassy materials are non-crystallized silicates containing other oxides, which influence the glass properties. The other advantage of glass is that it is very easy to fabricate in various shapes. Here we will see how a glass bottle are made. Firstly, the factory equipment feed precisely amounts of raw material into a furnace. The mixture is then melted at a high temperature in the furnace until it becomes a molten material ready for formation. Molten glass gobs are cut by a perfect timed blade to ensure each gob is of equal weight before it goes into the forming machine. When molten glass gobs feed into the mold, blow and blow method are best used for glass bottle manufacturing. And you can see from this example, with skillful blowing and turning, all kinds of amazing shapes can be made by molten glass. Glass ceramics. Most glass can be made to transform from a non-crystalline state to a crystalline state by the purpose high-temperature heat treatment. And the product is a thin-grained polycrystalline materials, which is often called a glass ceramics. The glass ceramics will have a low coefficient of thermal expansion. The most common use for those materials are as ovenware and tableware, primarily because of their high strength, excellent resistance to thermal shock, and their high thermal conductivity compared to a normal glass material. Clay products. Most of the clay-based products have two broad classifications: the structural clay products and the wetwares. Structural clay products include building bricks, tiles, and sewer pipes. The wetware ceramics become wet after the high temperature firing. This group includes porcelain, pottery, tableware, china, and sanitary ware. The wetware products and the structural clay products use similar raw materials. Both are made from a mixture of different clays and sand. They consist of various combinations, include mostly silica and alumina, with a smaller amounts of other oxides, such as iron oxide, and so on. This inexpensive ingredient found naturally in great abundance is often used as mined without any upgrading of qualities. Here is another demonstration showing how tiles are made. The raw materials are put into a crusher machine or a milling machine, which breaks up the larger pieces to very tiny particles. The particles mixed with water and other additives to create a mixture that is suitable for making tiles. Then the clay is fed to the extrusion machine. A lock screw pushes the clay through a metal die. A sheet of material that will form the tiles is punched out of the machine. This process is known as extrusion. The tiles are cut to size and move on the line to the next stage of production. The tiles pass through a drying process to remove some of the moisture from the material. Then the tile is printed on the surface. It will form the pattern on the surface of the tile. Last step, the tile passes through the firing process in the kiln. The kiln is a long tunnel heated by gas heaters. In the first section of the kiln, the tile is dried at a low temperature to remove water from the clay. Once the tile has been dried sufficiently, the temperature in the kiln is raised to 1185 degrees centigrade. This is where the tile is fired. The detail of firing or sintering will be discussing later. Another kind of ceramics material is the refractory material. We usually see less in daily life. Refractory materials must be chemically and physically stable at a high temperature.
Refractories are heat-resistant ceramic materials that can withstand mechanical abuse and chemical erosion at very high temperatures. More heat-resistant than metal, refractories are essential to the production of iron and steel. Able to withstand chemical corrosion, they are must-haves in glass and aluminum manufacture. The material assumes an impressive variety of forms, broadly cataloged as shaped, unshaped, and ceramic fibers. Shaped products may have simple geometries or complex interlocking ones. Traditional bricks and blocks usually are pressed into shape and then fired in large industrial kilns. Depending on their size, composition, and application, shaped products may also be precast, fused, or pressed at high temperatures.
This photo shows refractory linings for furnace. It was built with many refractory bricks. The refractory ceramics are also chosen as crucibles and a ceramic mold. A crucible is a ceramic or metal container in which metals or other substances may be melted or subjected to very high temperature. Ceramic molds are used in investment casting. They have the most accuracy of all the various mold types available. The oxides of aluminum, silicon, and magnesium are the most important materials used in the manufacturing of refractories. Next kind of ceramics material is abrasive. Abrasive ceramics are used to wet, grind, or cut away other materials. Therefore, the prime requirement for this group of materials is hardness or wear resistance. In addition, a high degree of toughness is essential to ensure that abrasive particles don't easily fracture. Furthermore, high temperature may be produced from the abrasive friction force, so some refractoriness is also desirable. The more common ceramics abrasives include silicon carbide, tungsten carbide, aluminum oxide, and silicon sand. As you have seen just now, abrasives are used in several forms, bonded to grading wheels, as coated abrasives, and as loose grains. Actually, in the grading wheels, the abrasive particles are bonded to the wheel by means of glassy ceramic or an organic resin. Usually, cements are classified as one kind of traditional ceramics because they have the similar ingredients. But as a structural material, cements is quite different from ceramics, so we will not discuss cements here. Let's go back to the starting story of this video. You should know by now, What kind of ceramic material they belong to? Yes, they are clay products. The ancients made them by the same way that we make tiles or sanitary porcelain today. So, up until the past 6 or so years, the most important ceramics materials were termed as traditional ceramics. In the 20th century, new ceramics materials were developed for use in advanced ceramic engineering. Here we'll take a glance of a rough global ceramic market shares diagram. Construction ceramics accounts for 78% because building ceramics include cement, glass, bricks, and so on, and the world is now full of tall buildings. To our surprise, the abrasive ceramics has amount of market share. Abrasives are extremely commonplace and are used very extensively in a wide variety of industrial, domestic, and technological applications. At the same time, we noticed that the market share of advanced ceramics materials was below 70%. However, the advanced ceramic materials have now become the cornerstone of energy transformation, storage and supply, information technology, transportation systems, medical technology, and manufacturing technology. Unlike our ancient people, in the past decades years, significant progress has been made in understanding the fundamental character of those materials. We will explain advanced ceramics in the next separate video. Ceramics are a big family. Some you are familiar, some you heard first time. Now do you have any ideas about each ceramics application?